ignore me, or if you struggled on this problem, like I anticipate a lot of us probably did, it would be great to pay attention. So 3105, which I don't think came from last night's homework. I think it came from well, it depends on when you did what. But it was either Tuesday or Wednesday's homework. Please make sure you realize that between Tuesday and Wednesday, we had 3 assignments. So I was helping somebody and I realized like they had missed the 3.2.4 assignment. So please make sure you have all 3 of those. So this 3-105 comes from 3.2.4, the last problem I asked you to do. And I really did want you guys to try this and critically think about it. Now, I was helping one of your classmates, and we were analyzing this, trying to figure out what the heck is going on. And we were looking at, okay, this is a difference of 12. This is a difference of 1.2. This is a difference of 0.8. We would guess that this is probably going to be 4. So, is there like a pattern happening here?
I mean, it probably is.
Bougainville?
24 divided by x.
Okay. You are like, do you walk in the movie and tell everyone who dies at the end?
Yeah. He's that
Hey, they blow up the Death Star at the end of this one. So, Bougainville just like spoiled everything. So, Bougainville's a spoiler. Be careful. So let me wrap some of this in a nicer package. And I should put your homework and stuff up top and so we can see the counter. By the way, if you're ignoring me right now, that's perfectly fine, but I'm on here so I can't see the counter. But you should be doing something productive, right? If you're ignoring me or if you already did this one, we can't see a pattern here because there isn't one. The change happening, even if I figure out that this is going to be 8, and then okay, so that change is 4, this change is 2. It's really awkward. So the next thing we do, and I'm teaching beyond where you need to know, but it's beneficial to get this started in your brain right now. Look at the change in the change. Okay, so that was a difference of 8. That's a difference of 2. And I don't see a pattern again. Right? So there's no pattern here. There's no pattern there. Scrap it. Forget it. Try something else. So Bougainville realized, what if I look at how these interact with each other compared to how these could interact with each other compared to how this could interact or this could interact. Things that they've given me, skip the things that we're not certain about. And Bougainville realized, and this is kind of like letting the cat out of the bag. Who was I working on this morning with? And why are we missing so many people? I'm really confused. This is really okay. So I'm gonna have to. I think it was Bilal. Was working with me this morning, and now I'm gonna need to like email him this video. So we were working through looking at the change and the change and the change, and we're like, crap, we can't figure this out. So if we look at how these relate to each other, though, Bougainville, how can you make sense of what the x and y are here? If you said x times y equals something, what would that be like? We try to make sense of it in a real situation. You have one value times another value. What can that represent? Or anybody. What can a number times a number, what do we represent? Yeah.
A number times a number?
Okay, but like give me a situation that it could be representing.
Wait, do you mean like a situation like how could a multiplication problem be represented?
And don't say the product of the x and y. We know that. So this is what Bougainville told us, right? The product between them is 24. Ready to get your brain blown?
Yes.
I haven't in 6 years.
And kick it under his desk.
This table is showing you the dimensions of a rectangle that has to have an area of 24. If the length is 1, well, then the width has to be 24. If the length is 2, the width has to be 12, and so on.
You just told us that in the beginning. That just would have been so much.
Do we get it?
Sure. It makes me mad, but yeah.
Now, here's the real thing, and I don't need you to actually answer. How many of you had not figured this out, and yet you weren't going to ask a question about it? And I don't need like you to tell me, but realize, make me work for my money, which is not very much money, but make me do my job. If something doesn't make sense, ask a question.
You mean you didn't realize it was a rectangle, or you didn't get the entire thing?
You like couldn't figure out what they were trying to get you to realize. Like, even if you figure out these numbers, if you don't know why, then you're not actually confident that those are right. Like, we could plug in an 8 and say, well, I think it is. And we could plug in a 4 and say, well, it's between 3 and 5. But until we know why and we can check, is this actually right, we're not sure. So then 8, what does this need to be? 24, what does this need to be? If this is x, this is the hardest part. Who?
24 divided by x.
Why? Oh, yeah.
Y will be the result of the division because it's the other factor, right? So x times y equals 24. Y would be the 24 divided by the x to get the other factor. 24 divided by 24 is 1. 24 divided by 12 is 2. 24 divided by 8 is 3. Any other homework questions we should talk about? Yeah, Scott? 114. You say boy or dog? Dog. Wait, which problem? 3-114, right? I am looking at the wrong chapter. That's from 2.5. So these are just a little bit tricky because we're working with like terms. Excuse me, that are missing. Well, not really missing, but they just aren't showing extra information. If I wrote banana on the board, you guys should not be surprised by these things anymore. I'm weird. So if I wrote banana on the board, what would you assume for the amount? 1, right? 1 banana. Do I need to put 1 for you to think, oh, there's 1 banana? No, I put banana, you assume there's 1, unless I tell you there are more than 1.
Or if you put bananas.
This x is a 1x, even though we don't put it there. So we have 1x minus 2/10 of an x. So think of 1 banana minus 2/10 of a banana. What you have left is 8/10 of the banana. So now that you see it, I saw you mouth it, like you realize now it's kind of easy, right? I thought you said, oh my gosh, like, oh, I get it. So that's good. And so like up here, this is a 1x. Now, a couple people I actually still need to meet with about like terms realize that this cannot combine with that. Remember, they're different shapes. That's a square, really 2 squares. These are rectangles, 3 of them, right? These are different shapes. They can't be combined. Okay, they're different shapes. They cannot be combined. Any other homework questions? We need to start, but yeah, 9. 103. Oh, I like this problem. That's why I kept it. 8 songs every 10 minutes. So my generation was the first generation of downloading songs. 8 songs would have taken me probably about an hour to download back in the day. So Jasmine, who's also downloading songs, can download at 12 songs every 15 minutes. And it's the same units, right? Songs and minutes. Who's downloading faster? So you want a rate. We can either look at a rate of songs per minute or minutes per song. When we talk about rates involving time, it's up to you. So we can do that too. When we work with speed over time, right? But here, I'd almost rather do time over song. It's up to you. It really doesn't matter. Like, I swear to you, it doesn't matter what you choose. You just got to be able to compare. Yes. I don't know. I haven't solved. So if I do minutes per song, I can do 10 over 8, and that's like 1.2 minutes per song here. Or no, sorry, 1 with a remainder of 2, 1, 2, 8, 1.25. 1.25 minutes per song. Minutes per song. If I do my 15 minutes divided by 12, I get 1 3/12, which is 1 1/4, so 1.25. The same. And that again would be minutes per song. If I flip it over and I do songs per minute, 8 divided by 10, 0.8 of a song in a minute, which to me is more complicated. Like, wait, I got a part of a song in an entire minute. I'd rather know just how much time it took me for the whole song. But that's me. It doesn't matter. Here, we do 12 divided by 15. If you do that division, or you simplify up to hundredths, you get 8 hundredths. Same thing. Alright, we got to dive into the lesson. We today are now moving into chapter 4, and we're skipping the first lesson. 4.1.2.
Okay.
So, in case you still need it. So, essentially, your homework is the odds from 17 to 29, skip 23. Because it's a lesson problem. Yeah, we talked about this yesterday. I forgot. I appreciate that. That's good. My wife doesn't. No, there's a meme that says, like, 90% of marriage is yelling what from the other room. And it's kind of accurate. You're like, hey, what do you want for dinner? What? All right, 4.1.2. What's up, man? Oh, yeah, you can do like 2/3. So, really, you can just title this Seeing Growth. Or Representing Growth. Up to you. But we're going to, like, look at how we recognize growth and how we represent it. So, recognize and represent. We had a really good start to this looking at that table. Right, we could not recognize consistent growth or consistent decay, like when we lose things. So it wasn't consistent. We had to change our thinking. So in lesson 4.1.1, well, we skipped that, so forget that. Throughout this chapter, you will explore connections between and find efficient ways to move from one type of representation to another. Like we're used to doing fraction, decimal, percent, or table to a graph to an equation. We're going to change how we represent it. So, as we work, keep these questions in mind. How can we see growth in a rule? Are we consistently adding something or consistently multiplying something, or subtraction or division? How do we know it's correct? Did we test it? Did it hold true? What does the representation actually tell us? And what are the actual connections? Like if we apply it to a real situation, the area of the rectangle is 24. Apply it to something physical. So if you have the resource page from the back, please check it out. We have figure 1, 2, and 3 here. I want you guys to, in whatever manner you would like, I'm going to go a little bit rogue from here, explore this figure. You can either make like a table of the squares that you need for the figure number. You can try to write an equation for the squares that you need for the figure number. What we're going to end up doing, and you can use whatever variables you want, is say the squares necessary when we have the figure number, which we could also just call n if we want, we often do that. So this, I'm going to teach you something again beyond what you have to know. A type of notation we use in math is called subscripts. If I do s with a little n, that means the s value at n. We also use a notation that's s of n, which means the value of s when n is my input. This is not multiplication. This is saying what is s when n has been put in. And the other way that we do this is just say s equals. We don't write it any other way. So there's multiple ways we can represent this. We want the number of squares. When we know the figure number, we might be adding or subtracting something. We might be multiplying by something. I don't know. Investigate it with your partner. Question? Then I'm coming back to you. You're looking at recursive sequence. Do you remember that? Does that ring any bells? So a recursive sequence is something that uses the one that comes before it. So if you say you tell me like you add 5 every time, then you could say the value at term 7 will be the value of term 6 plus 5. But the problem is you have to know how many were in term 6. And to know term 6, you have to know term 5. And to know term 5, you have to know term 4. So that gets us into a tricky situation where if you're only referencing the one that comes before, and so there's a lot of different ways that we look at sequences. I'm a little apprehensive to talk real deep with you because there's so many different, we got to set up some foundations before we go too deep. Like I was literally working through problems like that on the high school math 1 class, kid that I tutored last night. They were working through recursive sequences. So you're looking at stuff way beyond where you need to be. Yeah, I mean, we're working through A through D. If you're able to, we're working through A through D. Yeah, or in your notes. Alright, so figure 1 has 6. You can still ignore me if you want. This has 10. 8. So we add 4 every time. Okay, so we see what change is happening. Right, we're adding 4 to my amount of squares. Why are we adding 4? Can you tell me like what it looks like, what's happening actually? Will?
Okay, so what happens in figure 1 is like just a square with like 2 little things at the corners. And then in figure 2, it becomes a rectangle and it adds 1 little thing to the right or left, depending on how you see it.
So you can
and
say
it
that
adds
gets
1
added.
to the corners.
Ah, so depending on whether you want to say those got added or those got added, or that popped up in the middle and pushed it. So like, I kind of like that where things pop. Now here, it can't pop in the middle, but it could still say like it added 2 on. So yeah, we gained 4 like that. We'll do that again, and 2 in there. But that doesn't really help us formalize it. We wanted to figure out figure 10 or figure 100 or further figures out. So then it asked us to sketch, and we can sketch figure 4. Right? We'll add 2 in the middle and add 2 on the corners. But figure 0, weird. Izzy?
I think it's this thing. It's a domino. I call it domino.
So figure 0 is just 2 little blocks?
Yeah, because then when you go to figure 1, that's when the 2 little things appear in 1.
Ah, so 2 more appear in the middle and then 2 appear in the corner. So we could say, if I use that little subscript notation, the squares at figure 0, right? That is 2. The squares at figure 1 is 6. We could keep going. How could I write this as a formula for squares needed with an input of what figure number you're at? If we're always adding 4. Alex?
Well, I just said 4n plus 2.
Ah.
Because if you were to think about it, like if you multiply, well, let's say figure 0. 6, like in figure 0, if it's 4 times 0 plus 2, then it would be 2. And if then on the next one, if it was 4 times 1 plus 2, then it would equal 6. So
Yeah. So one way that we can look at this is what happens if we jump? If I would add 4, add 4, add 4, well then I really just add 4 multiple times. And to do that more easily, we just multiply. Right? So Alex said, we're going to say 4 times however many steps we've taken, right? Figure 1 or figure 2 or figure. Every time we take a step, we add 4. And we have those extra 2 in the middle. Yep, so that's 4 and plus 2. That's what I wrote. Well, you don't have to have the dot for the multiplication.
I like the dot. It looks clean.
So the squares we need are 4 times the number of the figure plus 2. Any questions on that one? Make sure you have that written somewhere on your resource page near that, so when you come back to the resource page, you can remember what we figured out. Look at the, well, let's make sure that we, so figure 100 now, instead of having to add 4 100 times, or actually 99 times, right, if we started at 1. What do I do? Fiber?
You just multiply. You literally do the equation you have right now, and you substitute the n.
Thank you for using that word. We substitute. You guys, are we good?
Yeah.
Okay, just checking. We substitute in what we know, and then solve it, and then simplify. Or 102, or 1,000, or 874, or wherever you want to go. Doesn't really matter. You just sub in what figure you want to go to. So we get that the number of squares that one would need would be 402, which was actually my Boy Scout troop number. Shout out to 402. But 402, like you have a Scout troop that would give a what you like. We are Phoenix. Scout groups are broken up into like what group are you, as opposed to saying you're a student. That would be like saying I'm a Scout. Okay, great. There's a lot of you. Okay, where do you go? You go to Phoenix.
It's like
Group
a
number
number
like
that,
your school for.
Yeah, it's like it's your unit. It's your identifier.
like, yeah, I see Girl Scouts one group is like 18.
Yeah. All right. Look at 13. We now are looking at this cross pattern or the really awkward, funky U pattern. Check those out. I'm going to give you guys a few minutes to really work on these. You want to try to formalize this and get it to a point where we can write an equation for it. So please try this out. It will often help you if you think about what would figure 0 be. Yep, go for it. You and your partner.
on the floor. Make sure that we're actually drawing stuff on here too, so it makes sense if you come back to this while you're working on your homework.
Guys, that resource page, this isn't like, hey, use it during class and then get rid of it. You want to use that while you're working through your homework and everything, so please make sure we are drawing on there and writing some stuff on there. Your journal, your notes, those are your primary resource, but these resource pages are very useful. So Izzy can help you figure 0 for tile pattern A. If anyone thinks that they know how to draw figure 0 for B, do you? Actually, no. Do you?
Yeah.
All right, come on up, give it a shot. Can you fit it in that space off to the left? Can you fit it in the space off to the left?
Oh, I can't.
Okay.
I can't now.
You hesitated.
Yeah, I just like jumped.
Wait, I'm gonna put this in a second.
There's a thing there on.
It's gonna get a little hard to draw because it's just big. Well, I on graph paper
Don't
it's
mess
easy,
this up.
but up here it's gonna be kind of hard to draw. Wow, that was bad.
You look worse than mine.
I really suck at drawing on smartboards. I have an idea for what we're gonna do to make figure 5.
Oh my gosh,
Bro, don't use green. How many times do I have to say the green pen slot?
Oh.
Okay, the color of this has nothing to do with anything. The color of this. And my smartboard is goofed up.
Wow, I suck at drawing on these things.
You might get new buildings.
Like that.
You do
Oh,
it.
smartboards.
Worthington is building, like we're gonna have.
Don't mess up your pen.
I'll do it. Okay.
Just draw the original shape and then draw the lines in between the shapes.
You have 10 seconds to figure it out before a better problem solver gets to take over for you. You're being theatrical about your struggles.
I can't get it. It's off
Alright.
center.
I know. But you just gotta figure out how to work with it. Try it. If you can't, we'll do it. I'll do it.
I don't care how crappy mine looks.
Okay, I heard a wait. Hold on, okay, grab a seat. That's a good attempt. We're not quite there. Right, so that's close. What edit? You said wait, right?
Yeah.
And what edit would you make to Will's drawing?
I'd add 1 on top of the right side.
Okay.
Oh, yeah.
Any other edit
Yeah, I would.
suggestions?
Yeah, I would too.
Oh, Ian's saying add 2 on top of the right side.
Oh,
Let's look at
yeah.
what doesn't
Yeah.
change. Right? So, can anyone tell me what doesn't change as we move from figure to figure to figure?
The right side stays 3 tall.
The right side stays 3 tall. Right? 3 tall, 3 tall, 3 tall.
In the middle.
The middle 2, middle 2, middle 2, middle 2. So if we look at what is changing, like Abe, what would you say as we go from 1 to 2? What is changing? It's all good.
There's 1 being added to the left side,
Thank you.
and then the right side, there's 3 being added.
Okay. 1 over there, 3 over here. So if I go backwards, we start taking those off. So if I go backwards to here, we took this 3 off. We took this 1 off. Those are gone. So now this 3 and this 1. Wait, is Will's right? Here's where your brain can get tricked or tripped, whichever you want to say. My brain just got confused. You can get tripped up because if you look at it as adding 2 blocks on, or something like your brain doesn't quite see that we're actually adding on 3, you'll get goofed up. figure out what is changing as we move forward, then go backwards. So now we peel these off, and we peel that, and this is actually right. But I heard a lot of people doubting Will as he wrote it up here, so I figured we should talk about it. So that's your figure 0. So figure 4, I'm just going to draw figure 4 right over here, would add 3 on here, and would add 1 on up here, right? And that would be figure 4. What if I wanted to say figure N, and you guys told me that the middle 2 stay there, or is it middle 2, or can we really say like the 3 stay there? The 3, right? Because here we have those 3, there we have those 3, where we start we have those 3, so we always have those 3. Then, how could you describe the amount of squares that go up here for any of these, and the amount of squares out there for any of them? Izzy? Sure. Audible gas.
Actually, it was a throat gas. So she went.
It's like this one, the 2 is here. This one, the 1 is here. This one, the 3 is here.
I get what you're saying, but
I get it too.
sure, you can write whatever you want.
So for figure 1, it's 1, and there's 1 here. For 2, there's 2, and there's 2 here. For 3, there's 3, and there's 3 here.
So she's saying this amount stacked on top of here
Is the figure number.
is the figure number. So the amount of squares this takes up is N. The amount of squares in this section is the figure number times 3. And this is always just 3.
This actually really
So we have 3n plus n plus 3. And we'll go back to A. But for B, the number of squares we're going to need is 4n plus 3. If we think about the any figure up here, well, we know figure 0 is just that square in the middle. How could you describe the squares going up, the squares going out, the squares going down, and the squares going out? Piper, you just made a statement that makes me think you might have this all wrapped together.
Not really, but I just noticed that on all of them, they seem to be 4n, sorry, 4n plus a different amount, because the figure 0 is different when that's what you add on. That seems to be really the only difference between them, but I haven't finished number 4 yet.
So check this out. How do the pieces that are growing compare to the figure number? Alana, I saw your gears turning.
Sorry, so the third figure, it has like 3 on the side.
And the second figure has
2.
and so these we could always say will be n. That's a highlighter. N and n and n and n. Whatever the figure number is, we're gonna have that many squares and a 1 in the middle. So this formula, 4n plus 1.
Is it actually going to be 4n plus 4?
I don't know.
No, I hope so. I don't think that'd be funny.
Try. You got one more down there, right? Try the one at the bottom. Yeah. Give me a moment to get there. But yes. because we've been taking time to check homework and everything else, we did not get all the way into lesson 413. So we're quickly going to try to cover that tomorrow and then still get through 414. So still try to do all those homework problems. Can you not talk at the same time as me, please? It's really frustrating because I like you, but that's annoying.
Sorry for my bad drawing ball.
No, it's better than I could do. So go ahead. Can anyone explain how she thinks figure 4 is that? Right?
Every time, if you look at the growth on every two, so now all of them are only adding 2 on the left and right sides. So if you look at figure 2, it has 2 right there that were added on the plus, and then you have over there that has it too.
To figure out this, I'm assuming at least, that Piper had to first look at the difference between 1 and 2. And what she did, we go from the T to the T with these being new. And then these are new when we go from 2 to 3. So as we back up, peel off the left and right, peel off the left and right. That's how Piper figured out what was happening. We're adding to the left and right. So we peel these off, and that's how Will got his figure 0.
It's more like 2/3 and a quarter.
Ah, so the squares we need, the growth is 2. So we're going to say 2n. We've grown 2 for every step we've taken. Plus, how many did we have when we hadn't grown at all? 3. Questions? Is this making sense? Alright, especially since we're missing so many of our peers for COSI on wheels. I mean, we're missing enough that I don't really want to move on and just rush. Take the next like 5-ish minutes to work on homework. Actually, if you go on CPM's website, there's a ton of things. Yeah, so if you go to CPM and search like tile growth or tile patterns or anything like that, and it'll pop up with stuff. Or you can even Google like finding tile growth or anything else like that.
It's really funny is when you have to and then you also have to grab the
We're getting there.